Hello and a very warm welcome to this next chapter on epidemiology. I'm so excited to have you all back again for learning epidemiology. If you are doing your undergrad studies, if you are in third year or second year or whatever exam you're going to appear for your UG exam for community medicine, this is the chapter which is a life-saving chapter because a lot of questions come from this. You'll have a special viva on epidemiology, short answers, long answers, MCQs in epidemiology. And if you are a PG student who's preparing this whole chapter, we are going to spend minimum 3-4 hours on learning epidemiology, is going to fetch you 3-4 MCQs at least in your exams. And those 3-4 MCQs will define what branch we get in our exams, right? So let's get on and talk about this whole chapter on epidemiology. For the ease of MCQs, I have divided this chapter on epidemiology into 3 broad sections. We need to talk about the basics in epidemiology, basic MCQs. Then is one of the most sought after topic. This topic is a 5 by 5 star MCQ topic for your exams. We are going to talk about the epidemiological methods in which we will talk about the descriptive epidemiology, analytical epidemiology, advanced analytical epidemiology. What do you mean by intervention trials, experimental trials, evidence-based medicine, and so on. And last topic will be causality and errors. Again, a 3 by 5 star MCQ topic. A lot of questions come on this. So let us get on, and in this video module, we are going to talk about the first basic topic, basics in epidemiology. So this whole chapter on epidemiology or the concepts in epidemiology cannot start before paying respect to this great man. This is Dr. John M. Last, and from your MCQ exam perspective, you should know that Dr. John M. Last, a Canadian researcher, he gave us the definition of epidemiology. He gave us the iceberg principles that we study in epidemiology by Dr. John M. Last. Next topic is what do we mean by epidemiology? What is epidemiology? If you talk about epidemiology, what does it mean? See, epidemiology is made up of 3 words, epi, demios, and ology. Epi means among, demios means a population, and ology means a study. So you will say that this is a study among the population. Then you'll say that, sir, you did the same thing in demography. In demography, it is demios and graphy. It is a study of the population. So how is it different from study among the population? See, let us say that I give you a small game. Let us say that a 50-year-old male, he comes to you with a very high-grade fever in your OPD. And there were some black spots on the forearm. And suddenly, let us say this person comes to you on 1st of June, and by 4th of June, you give that patient some antipyretic, some laboratory investigations you do. Malaria was negative, typhoid negative, dengue negative, any viral markers we did, COVID negative, anything was negative. So 50-year-old male, he presented with a very high-grade fever, and then by 4th of June, let us say unfortunately that patient expires. And let's say that maybe on 6th of June, you get 7 more cases like these or 8 more cases. What are we going to do? So the point I want you to understand is that what are we? We are all doctors. And what are doctors? Doctors are simple mechanics. I want you to appreciate this point that we all are simple mechanics of a machine called as human body. You know how the human body functions. What is the physiological function? You know that if there is some microorganism or some agent into our body, there might be some abnormality, which we call it as the pathology of the disease. And then you know that what is causing it, and then you can treat it. I want you to appreciate that you cannot treat a disease until and unless you don't know what is causing the disease. And the science which tells you, in one word, if you ask me what is epidemiology, the science which tells you causation. The science which tells you causation, that what is going to cause a disease, is what is epidemiology. And to find the causation, you have to do a study among the population, within the population. That's what is the use of epidemiology, and that's what is the aim of epidemiology. So for your MCQ exams, for your UG exams, please note what is aim of epidemiology. It is to study how much the disease happens in an area, when did it happen, where did it happen, when did it happen, where did it happen, is all understanding about epidemiology. It also, the epidemiological exercise or the methods will also tell you that why the disease happened and what are the, please note, What are the associated or causative factors? There may be many factors which may be associated. Listen carefully. There may be many factors which are associated with the disease, but out of those associated factors, which factor is actually causing the disease is what do you mean by causality? So the second aim of epidemiology is to establish causality. In fact, this is one of the most important areas of epidemiological exercise or the epidemiological methods that we are going to study, and how to prevent or control the disease is what is the another aim of epidemiology. So based on this, if you understand the aims, now let us talk about what is the definition of epidemiology. What is the definition of epidemiology? What is epidemiology, beta? It is a study of the distribution. It is a study of distribution. It is a study of distribution and determinants of health-related states or events, right? And measures to control or prevent the disease. This is the definition, classical definition of epidemiology. It is a study of the distribution and determinants of health-related states or events and measures to control or prevent the disease. So technically, if you see from my eyes, I see three parts of this definition. It is a study of the distribution, it is a study of the determinants, and it is a method to control or prevent the disease. Where will you study distribution of disease? Just now we had done that the distribution of disease, you are going to study in how much and where we are going to study the disease, right? Next is, if you talk about where will you study the determinants of disease? Determinants, you are going to study where, that what are the associated or the causative factors. And next is that the measures to control or prevent, and that was the third aim. In fact, the aim of epidemiology is the definition of epidemiology, right? So that is what is we are going to study in this whole section of epidemiology. It is a study of the distribution. So distribution means what? You need to do some descriptive studies. You need to do some descriptive studies. That is what is understanding about the method of distribution, to study of the distribution of disease. And determinants, that is, you're going to do some analytical studies to find out which factors are causative, which are not causative of health-related states or events. So mind it, just nothing very big, that it is not about the disease that we are talking. It is about health-related states or events and measures to control or prevent the disease. Where will you study this topic, measures to control or prevent the disease? Don't you think that you're going to study this topic, or probably you must have already studied this topic, how to prevent or control a disease? This is nothing but the National Health Program. Am I correct? Like National Health, what is National Health Program? It is a way, epidemiological way to prevent a disease. By knowing that what are the factors, and if you treat or if you remove those factors, of course, the disease is not going to happen, right? So that is what is the definition of epidemiology. Please note that the definition of epidemiology was given by Dr. John M. Last. It was given in 1988, so that's not very long ago. And this is a relatively newer field of epidemiology. The next is topic number 2. We need to talk about what are the tools of measurement. So in the tools of measurement, we need to talk what do you mean by a ratio, a rate, and what do we mean by a proportion. What is a proportion? So beta, please note that there is always a numerator and there is a concept of denominator, right? Very simple. Numerator will be there, denominator will be there. In a ratio, please note always the numerator is from different area. The denominator is from different area in a ratio. Whereas in a rate, the numerator is out of the total denominator, and in proportion, the numerator is out of total denominator. I hope you understand. There is a numerator, that is the top part of the fraction, and there is a denominator. So if the numerator is separate, denominator is separate, they both are from different areas. That is, nothing is related between the numerator and the denominator. The numerator is not out of the denominator. That is called as a ratio. Very simple. So that means it brings us to an understanding that any entity, any variable, it could either be a ratio or it could be a non-ratio. The non-ratio could be a rate or it could be proportion. Point number 1 done. So please note, first in your MCQ exams, you need to see that whether the entity the examiner has asked, whether it is a numerator and denominator, are they out of the same population or is it different? Next in line is, when do you call a rate? See, my heart beats at the rate of 70. What 70? 70 beats per minute. We will ask you that you go and run to that patient and put the dropper set at 20 drops. What 20 drops? 20 drops per minute. 16 drops per minute. You set the infusion at rate of 0.5, 0.05 ml per minute or per hour for insulins or any infusions, right? And let us say that my car travels at the rate of 100. What 100? 100 kilometers per hour. So whenever we are talking of rate, beta, whenever we are talking of rate always means hamesha, always means always expressed in time. So if there is time, it is a rate. Okay. Whenever we are talking of proportions, whenever we will talk about proportions, in proportions, we always expressed in percentages, or the multiplicative factor is always 100. It means the same, right? So if you are expressing it in percentages or in 100, it is proportion. If there is time, it is a rate. And if the numerator is separate, denominator is separate, it is a ratio. So let's take an example, a lot of examples over here. Can you tell me, what do you mean by MMR? What is MMR? MMR stands for maternal mortality ratio. It stands for maternal mortality ratio. Please note, it's not a rate. It is not a rate, it is a maternal mortality ratio. What is the formula of maternal mortality ratio? The formula of maternal mortality ratio, it is given by the number of maternal deaths. Number of maternal deaths divided by the total live births in the area. It is number of maternal deaths divided by total live births in the area. Multiplicative factor is 100,000 or 1 lakh. So mummy deaths or the mother deaths or the maternal deaths, that is separate. The live birth is separate. So mother deaths is separate and live births is separate. That is the reason we call this as a ratio. Let us say that the examiner gets stuck on the idea that can you tell me what is the formula of maternal mortality rate? If the examiner gets stuck on this idea that I want the maternal mortality rate, can you be smart enough to answer that examiner? Yes, you are indeed smart enough. You are going to say that, sir or madam. Let us say we are talking of the number of maternal deaths. MD is maternal deaths, right? So number of maternal deaths that happen in an area divided by the total number of what? Divided by what? Divided by something. I'm telling you, we are talking about rate. So number of mother deaths divided by something. So divided by total pregnancies you can answer, total WRA females answer, total females you can answer, right? So if you answer total pregnancies, that is not a very good answer. Total pregnancies, if you answer, that is not a very good answer, because people who are actually pregnant, you don't know. In government, we don't know who's pregnant, right? So the female will also come to know only after second or third trimester, month or something like this, right? So we actually don't know how many females would be pregnant. So, but yes, we definitely know that what is the total number of WRA females into 100,000. This is technically a formula of maternal mortality rate. I hope you understand what do you mean by a ratio and what is a rate. Please note, the ratio is a maternal mortality ratio. What is maternal mortality ratio, beta? What is the formula? Please note, no mistakes on this. If you do a mistake, that is absolutely a silly mistake, I would say. What is the formula of maternal mortality ratio? It is number of maternal deaths divided by the total live births into lakh. What is the formula of maternal mortality rate? What is the formula for maternal mortality rate? It is the total number of maternal deaths divided by the females in WRA. What do you mean by WRA? Please note, females in WRA. WRA stands for women in reproductive age group. Women in reproductive age group. So we are talking about the females in WRA. That is the females or the women in reproductive age group. So that is what is a ratio and that is what is a rate. Can you tell me now, what do you mean by incidence? What is incidence? Of course, we have not done it right now, but probably you must be having some understanding that what do you mean by incidence. Beta, incidence is the number of, just grossly I'm saying, it is the number of new cases It is the number of new cases. What do you mean by the prevalence? Prevalence is the number of old plus new cases. So please note, this is just a very gross definition because we are going to talk in detail about what do you mean by incidence and what do you mean by prevalence. But over here, I want to make a point over here. The point that I want to make is that do you know what is incidence? Is it a ratio? Is it a rate? Or is it a proportion? Please note, if you study any book, any Harrison or any textbook that which is a reference standard textbook, they will always say that the incidence of any disease like cystic fibrosis or any rare disease or any disease is 1.1 cases per lakh population per year. Can you tell that the incidence of diabetes is 50? What 50? What 50? 50 cannot be the incidence. 50, you have to say that 50 cases per thousand population, per lakh population, per month, per year. You have to say some time. So incidence cannot be said without time. So what is incidence? Incidence would primarily, you would put under the heading of rate. Incidence would primarily be put under the heading of rate. Next in line is, I asked you like, what do you mean by the prevalence? Next is, I asked, what do you mean by the prevalence? Prevalence is the total new cases and old cases. Let us say that the prevalence of low birth weight in India, it's roughly hanging around 20%. 20% is the low birth weight prevalence. So what is prevalence? Is it a rate, a ratio, or proportion? So technically, if you say, I know there are different schools of thought, different books will say it differently, but generally speaking, if you just look at prevalence from a gross overall view, what is prevalence? Please note that the prevalence is always expressed in percentage. You talk about the total number of COPD cases. So you know that the prevalence of COPD in India is roughly around 7 to 8%. What do you say? Do you ever say 7 to 8% per year per thousand population? No, we just say the prevalence. So please note that the prevalence is actually a proportion. It can also be expressed at rate. It can also be expressed in different terms. We can also express it as ratios, but generally speaking, prevalence would be always expressed in percentage. It is a proportion. Innately, it is a proportion, right? So we'll talk much more in detail about all these things, what is rate, ratio, proportion. But just before I leave this topic, can you tell me what is a case fatality rate? What is the formula for case fatality rate? What is a case fatality rate? Beta, case fatality rate is what is the total number of deaths due to a particular case, due to a particular condition, divided by the total cases of same condition. So that is what is a case fatality rate. Always the multiplicative factor is 100. Let us say that I ask you, can you tell me what is the case fatality rate for rabies? So what is the case fatality rate for rabies? It is 100%. Do you ever say it is 100% per year per thousand population? No. We just say that the case fatality rate for COVID was 5%. Case fatality rate for diphtheria in unimmunized is maybe 2%, 10%, 20%, whatever number. So case fatality rates are what? The name is a rate, mind it. The name is rate, case fatality rate, but it is always expressed as percentage and there is no funda of time. You don't say case fatality rate of rabies is 100% per thousand population per year. It doesn't happen like that. So we say about case fatality rate. Please note case fatality rate is actually a proportion, but the name also says it is a rate. So in your exam, you have to be very cautious. If the beta, just for your MCQ exams, I want to tell you, at first place, look at the numerator, denominator. Next in line, you look at whether there is time. If time is there, it has to be a rate. If the multiplicative factor is 100, it has to be a proportion. But even if the multiplicative factor is 100 and there is time, you have to switch with time. Because time is the most important factor for calling it any entity as a rate. The multiplicative factor in rates, the multiplication in proportion is 100. So in rates, it is usually 1,000, it could be 10,000, it could be 1 lakh, whatever number. But usually it's not 100. If it's 100, you look at the time. If there is time, it's a rate. If there is no time, so obviously that goes with the proportion. So based on that understanding, rate, ratio, proportion, let us come to topic number 3. What do you mean by the measures of morbidity? What is morbidity? Morbidity, beta, morbidity means illness. It means sickness. It means disease. So how do you measure morbidity? Morbidity can be measured in two terms. You can talk about the incidence of disease, or we can talk about the prevalence of disease. So we can talk about the incidence or the prevalence. What do you mean by incidence? Incidence is the total number of new cases per unit time in a defined population. In a defined population, that is what you mean by incidence. So it is the total number of new cases per unit time in a given time in a defined population. That is what is incidence. What do you mean by prevalence? It is the total cases. It is the total cases. That means it consists the old cases plus the new cases. It is the total present cases. So total cases in a defined area, in a defined population, is called as prevalence. It is almost always expressed as per 100 population. So usually we express prevalence in per 100 population. If you just talk about what is a prevalence and what is incidence, let us say that this is the world. Just imagine that this is the world. This is just my own hypothesis. This is what epidemiology I know of. So I'm just sharing with you my own understanding about community medicine, about epidemiology right now. So let us say that this is the whole globe. So I believe that in this world, in this universe, there are superpowers. So God is there. And they already have made a lot of buckets. Just imagine there are some jugs or buckets or tubs of diseases. I believe that if this is the whole world, in this world there are TB bucket, there is a bucket for cancer, there is a bucket for heart attacks or myocardial infarction or the coronary artery disease, there is a bucket for maybe diabetes mellitus, there is a bucket for hypertension, and you have a lot of buckets, thousands of buckets. There will be common sense, some people who land up into one bucket. There might be some people who land up into multiple buckets. They fall into TB and cancer and diabetes, and there could be some people who don't fall into any bucket, right? So that's how I think my world is, that for every disease, there is a bucket. So now let us talk about one single bucket. Let us talk about one single bucket. Of course, there are many buckets. Let us say we are talking of diabetes or cancer or hypertension or coronary artery or tuberculosis or any disease. So let us say there is some disease. The number of, listen very carefully, the number of new people who fall into this disease, into this bucket. What are these called as? These are called as, I think these are called as the incident cases. The number of people who are already present in this bucket. There will be some people who are present in this jug. The number of people who are present in this jug, these are called as the prevalent cases. They are present cases. That's how I have remembered. Now the funda I want you to understand is that these prevalent cases, they will have only three options in their life. Either some of them will get cured, and if they get cured, they join back the world. So either there is a cure or a treatment for that prevalent cases, or unfortunately, some of the people may actually die. So if they die, of course, they are out of the universe. So that's just my understanding, that a person with disease can have three options. Either you get cured and join back the world, or a person will die, they are out of the game, or they stay as the prevalent cases. There are only three options. Any disease will have common sense, right? So number of new cases who fall into a bucket is called as incident cases. Number of present cases are called as prevalent cases. There are only three options. Either you stay prevalent, or you die, or there is a cure for that disease. Now, if you understand this game, let me ask you a MCQ over here. The MCQ I'm going to ask you is that, let us say you are a very beautiful researcher. You are a big person now, and let us say that you invent a new drug. You say that this is the new drug for cancer. This is a new drug for COVID. This is a new drug I have invented for epilepsy. This is a new drug which is going to stop people from dying, whatever number. So let us say there is a, listen carefully. Let us say there is any non-communicable disease for which you invent a new drug. A new drug is there which is going to increase the cure. So if the cure is better or there is new drug, what will happen to the incidence and what will happen to the prevalence? This you are going to tell me. Can you tell me that whether the incidence will increase, prevalence will increase, or they both will decrease, or only incidence decrease, prevalence will not, or only prevalence will decrease, incidence will not? What do you want to say? Or do you want to say that maybe incidence increase, prevalence decrease, or incidence decrease, prevalence increase, whatever options you can take? So please note that what concept over here I want to bring to you is that if there is a disease, non-communicable, communicable, and if you increase the cure, the funda is you increase the cure. Beta, if you increase the cure, what are you going to do? That means more people are going to get cured. So if the cure is going to be more, that means what is going to happen to the prevalence? What is going to happen to the prevalence? The prevalence is going to come down. So if the prevalence is going to come down, either it is this, or this, right? Simple. So first is I want to train you, beta, that it is wrong somehow. In the medical schools, we have been teaching it is incidence and prevalence. Please note it is always prevalence followed by incidence. We are humans. We don't make disease. We don't make incidence. We are humans. We can either cure or we can kill, right? So we are humans. We are doctors. So we can change the cure or the death of the disease. That is, we can alter the prevalence. The incidence will be changed later on. So incidence is actually dependent on the prevalence. That's what I want you to understand. Always train your mind that you talk about the prevalence first. So beta, in this condition, what is going to decrease? It is the prevalence which is going to decrease. So now you focus your mind over here that what type of disease are you tackling? The question is saying it is a non-communicable disease. So if I say that you are going to treat a lot of cancers, diabetes mellitus, coronary artery disease, so you're treating, will it stop people from getting cancer? Answer is no. So the incidence, whatever God has made the incidence will keep on happening. So that means in a non-communicable disease, the incidence will not change, right? In the communicable disease, the incidence will change. So that is what your understanding should be. So what is the best answer over here? That the incidence is going to remain same and the prevalence is going to decrease. This will be my best answer. Now let us say examiner came to know that you already knew this. Now he was very clever and he acted smart and he said that for a communicable disease. Now he acted smart and he said that for a communicable disease, can you tell me which of the following is going to happen? So now if the question says that for a communicable disease, what is going to happen? Please note again the same funda, there is a good cure. If the good cure is there, common sense, the prevalence is going to decrease, but now it is a communicable disease. Now we are talking about smallpox, we are talking about poliomyelitis, we are talking about guinea worm disease, we are talking of leprosy, we are talking of so many communicable disease in the country. So how will you decrease the communicable disease? By decreasing the cases. Because the incidence comes from where? Where does this incidence come from? They come from the previous cases. So if the previous cases are low, the incidence will be low. Common sense. So please note if the question says that for a communicable disease, what is going to happen? For a communicable disease, both the incidence and the prevalence, they are going to decrease. Are you getting it? So take home message in this slide, I would like to tell you that in your exam, look at the prevalence first. Look at prevalence first. Then you see whether the disease is a communicable or non-communicable disease. In a communicable disease, the incidence will change with prevalence. In a communicable disease, the incidence will change with the prevalence, and in a non-communicable disease, the incidence will remain same because we do not make disease. The God is there. They have made disease at a particular level for human mankind, and that's how the graph should look like. Done? So that is one thing that you should know, that incidence will not change with the disease. So that was regarding what do you mean by the understanding of prevalence and incidence in the measures of morbidity. Point number 2. So question number 2, we are still on that measures of morbidity. What is the formula to find out the prevalence? Please note that the prevalence is given by a formula incidence into duration. Prevalence is given by the formula the incidence into the duration. I think it is very imperative, it is very common sense that the more the incidence of the disease, the more will be the prevalence of the disease. That is common sense. That stands true for almost every disease. And this is also common sense that if there is a more duration of the disease, the prevalence is going to increase. So if the disease is going to happen for a longer time, the prevalence will definitely increase. So coming over to the next point, point number 3. If you talk about the point number 3, what are the special incidence and special prevalence rate? Let us talk about the prevalence rate first. Beta, the prevalence rate can be of two types. We can have something called as a point prevalence, and we can have something called as a period prevalence. Very simple to understand prevalence. Very simple to understand that what is a point prevalence and what is a period prevalence. Point is at a given time. Point is at a given time. And what is a period prevalence? Period prevalence is within a given range, within a given time range. So very, very simple to understand. Just look at the screen now. So how many cases you see? So between 1st June and June 15th, within these 15 days, we found out that there were total 9 people who got disease. So there were some people who got disease before June 1st and there were some people who got disease after June 15th, right? So if I want to calculate the period prevalence means between the June 1st and the June 15th. If you want to see how many people were actually having disease within this time period, so you can definitely say, I think it is common sense that these all people had disease. And of course the 6 number also, but you will not include which person? You will not include number 3 and number 7. Why? Because they had the disease before or after. So very simple to understand, beta. If you talk about the period prevalence in this case, what is the period prevalence in this case? Total 9 cases, out of them 2 you're not counting. So how many are left out? It is the total 7 cases. So the period prevalence would be 7 out of 9 cases. So you can express it as 7 by 100 per 7 by 9 per 100 or whatever number. So, but the period prevalence over here is 7 cases. If you talk about the point prevalence, can you tell me that what is the point prevalence? Now the question is about the point. Point is at a given time. So what is the point prevalence on June 1st? Please note that the point prevalence on June 1st will be which all cases? Very simple. Nothing, no brainer. First case, second case, 6 and 9 number. So how many do you see on the 1st of June, right? You're not going to count the number 4. Why? Because 4 started the disease after 1st June. And you're not going to count number 3 because third happened before June 1st. So very simple to understand what is the point prevalence on June 1st. The point prevalence I see on June 1st is on June 1st is total 4 cases. I think that's what we had drawn, right? So total 4 cases were there on June 1st. And how many on June 15th? What is the point prevalence? Again, same answer. I think it's again 4 cases on June. Very simple to understand that these are the special prevalence rate. Coming over to the next topic, that what do you mean by the special incidence rate? The special incidence rates. So what do you mean by the special incidence rates? Beta, for your exam, you need to remember 2 important rates. What do you mean by the attack rates? And what do you mean by the secondary attack rates? What is attack rates? These are special incidence rates, and attack rates is given by the formula. It is the total number of new cases which happen in a given time in a population, in a defined population. So that is what is the numerator. Total number of new cases in a given time in a population divided by the total susceptible population. Usually the multiplicative factor for attack rates is taken as 1000, but common sense you can take it as per 1000, per million, per 10 lakh, per lakh, whatever number. For COVID cases, we found out the attack rates almost every day, right? We used to find out the attack rate of COVID per lakh population or per million population, depending on what is the size or the load of the COVID cases. So it is, please note, the total number of cases which happen in a given time in a given population divided by the total susceptible. That is what is a general attack rate. And the next one is, what do we mean by the secondary attack rates? But if we talk about the secondary attack rates, SAR stands for the secondary attack rates. It is given by the total number of secondary cases. Total number of secondary cases. What do you mean by secondary cases? These are the cases which arise from the primary case within an incubation period. Please note over here, I'm just trying to tell you what is special incidence rate, that is attack rate, secondary attack rate. The details of this we have already discussed in the chapter in infectious disease epidemiology and concepts in community health. So please note that it's just the formula that I'm narrating over here. Secondary attack rate is total number of secondary cases divided by the total susceptible population. Minus the primary case. Please note it is always minus the primary case and multiplicative factor is 100. This MCQ has been asked 1000 times. So the MCQ has asked about what is the numerator, the MCQ has asked what is the denominator, and MCQ has asked what is the multiplicative factor. So please note that in a secondary attack rate, the multiplicative factor is usually 100. It is almost always expressed as percentages in proportion. So although the name is a secondary attack rate, but in reality, it is a proportion because it talks about the percentages. But all said and done, you need to know what are the special incidence rates. You need to know what is the formula of attack rate, secondary attack rate, and these are special types of incidence rates. And special prevalence rate could be a period prevalence or a point prevalence. So based on now the similar understanding of what we learned in the rate ratio proportion, let us come to the next topic. Topic number 4. What do you mean by the measures of mortality? MCQ number 1. What is mortality? Mortality means deaths. Beta, please note this is a 3 by 5 star MCQ topic for your exams. So we are talking about the deaths. Let us say that we take a very common disease. We are talking about deaths due to tuberculosis. So there are different formulas you need to know. Many formulas are there. We are for MCQ purpose, I'm discussing just 4 formulas. So we are going to talk about the crude death rate, cause specific mortality rate, proportional mortality rate, and we are going to talk about the case fatality rate and the survival rates. So anyways, what is the formula for each of them? Let us start with first, what is the formula for cause specific death rates? If you're talking about a disease like tuberculosis, how many deaths cause specific death rate? See, cause specific, it is deaths due to a specific cause, like total number of deaths due to a specific cause like tuberculosis divided by what? That is what the question is. See, what is the formula for crude death rate? Crude death rate. What is the formula for crude death rate? Crude death rate is a very general formula. It is the total number of deaths. It does not talk about the TB. It is the total number of deaths due to a disease. Divided by what? Divided by the mid-year population. We already did this in demography. What is crude death rate? It is the total number of deaths due to any cause divided by the mid-year population multiplied always by 100. So what is mid-year population? Mid-year population is always done on 1st of July. So it is taken from 1st of July till 30th June every year, and that is what is the mid-year population. So what is crude death rate? It is the total deaths divided by the mid-year population multiplied by 1000. If you understand the crude death rate, what is the cause of specific death rate? It's the same formula, bache. It is deaths due to a particular cause divided by what? Divided by the mid-year population multiplied by same answer 1000. Well, now comes your answers. These are relatively easy. What is the formula for proportional mortality rate? Proportional. You remember what is rate ratio proportion? Proportion. So deaths due to a particular cause divided by the total deaths. And a proportional mortality rate. It is deaths due to tuberculosis or any disease due to specific disease divided by the total deaths multiplied by 100. That is what is a proportional mortality rate. Next in line is, what do you mean by the case fatality rate? Very simple. Case fatality rate is total deaths due to a particular disease divided by the total cases. We already did this. So what is the formula for case fatality rate? It is total number of deaths due to a disease, let us say TB, divided by the total cases of tuberculosis. Usually case fatality rate, the multiplicative factor is 100. There has been couple of questions coming on case fatality rate, beta. Case fatality rate. You already have done. What is the formula? It is always expressed in percentages. It is actually a proportion. Please note, case fatality rate does not account for time. It tells you what? It tells you the antigenicity, immunogenicity, the pathogenicity, or the virulence. Please note that the case fatality rate is a measure of the virulence of a disease. Virulence. What do you mean by virulence? Virulence tells you about the killing power of disease. Killing power of disease is what is virulence, and that is what you get questions on case fatality rate. Just exactly opposite of this case fatality rate is called as the case survival rate. That is a case survival rate. What do you mean by CSR? Case survival rate. What is the case fatality rate? Total number of deaths due to a particular disease divided by the cases. What is case survival rate? Common sense answer. It is a positive indicator. It is the total number of survivors or the total number of persons surviving that particular disease divided by the total number of cases of that particular disease multiplied by 100, that is a case survival rate. So case survival rate, can I say that it is nothing but 100 because it's in percentages minus the case fatality rate. So number of people who died minus 100 minus the number of people who died, that is what is the survivors, right? So as far as the survival rates are concerned, please note that we can measure the survival indices also. So one is measures of mortality, right? You measure the deaths. You can also measure the survivals. How do we do that? We can do a life table analysis. Life table analysis. What do you mean by a life table? So we draw a life table that when a patient would or a person would prematurely die. So of course this is the ideal method, but it is very difficult to make for most of the diseases. So what we do is a better statistical measure that we have. This is called as a Kaplan-Meier survival analysis. So the Kaplan-Meier graphs, they help you in what? They help you in measuring the survival. They help you in measuring the prognosis of a particular disease. So please note that Kaplan-Meier is a statistical measure. It is a statistical measure to find out about the survival in every disease. Another concept about that measures of mortality could be understanding for standardization, and a lot of MCQs come on this. This is a 2 by 5 star MCQ topic, high yield MCQ topic. What is standardization? Let us say two cities are there, city A and city B. Take for example, city A is the IT city and city B is a very old city, or people with the retired homes. There'll be more older population. Just imagine it's an old type of city where more people are there who are in the older age group. So in IT city, what age group people will be landing there? That will be the middle age group will be more. Common sense, it will not have many infants, it will not have many older people because it's a newly formed city, it is IT city. And in the city B, there were more older people, so obviously elderly was more. So where, let us say that the death rate in city A, if for example the death rate in city A was for example maybe 5%, 5 per 1,000, and in B population it was 10 per 1,000. Can we say, if you don't know the age group, if you do not know that whether it is middle age or elderly, if you just see this 5 and 10, can you say that the death rate in city B is higher than the death rate in city A? Common sense, yes, because 10 is more than 5. Can you say that the health services in city A are better than the B because there is lesser deaths? Of course not, because there are many determinants of having deaths. One of the major determinants is age. So whenever we are, listen carefully now, please note that in standardization, whenever we are comparing the death rates in different populations, you have to be very sure that the age structure of the population is same. Because if the age structure is same, then you can comment that the health facilities are better, not better, people better, not better, educated, not educated, rural, urban, what is happening. Provided the age structure should be same. Now that definitely will not happen in most of the places, most of the cities. You compare Delhi with Bangalore, you compare Chennai with Kolkata, you compare Kolkata with Gujarat. It's not Ahmedabad. You're not going to get the same demographic structure. So now to compare the death rate, that is what the whole game is. To compare the death rates, we always do standardization. MCQs on standardization. But a standardization can broadly be of two types. You don't want to go into too much detail. It's never been asked. But for your understanding, I'm just giving you a little bit understanding that how many types and what all are they. Standardization can broadly be classified into a direct standardization or indirect standardization. In both these standardization, please note, mark the words. I know that in many platforms, in many areas, in many books, it is given a wrong understanding is there in the students. So please note, in both the standardization, the direct or indirect, in both the standardization, we will use a standard population. So a standard population with age-specific death rates is used in both the standardization, the direct and the indirect. So when will you do a direct standardization? We will do a direct. If the age, listen carefully, if the age specific death rates of the population to be compared is available, then the standard population with the age specific death rate is there. You also have the age specific death rates of your comparing population. Now you do a direct standardization. Okay, so please note, in case, on the other hand, let us say that you were comparing some city A and city B for which the age specific death rates, just imagine that the age specific, how many people die, you know the total deaths. But do you know that 5 to 10 years, how many die, 10 to 15, how many die, 15, 20, how many die, 20, 25, how many die? So in those cases, if the age specific death rates, of the comparing population or the standardizing population is not known, if the age specific death rates of the comparing population is not known, in those cases we have to do indirect standardization. So when do you do direct standardization? This is the standard population. I will do direct standardization if the age specific death rates of my comparing population is known. I will compare them directly with the standard population. So direct standardization done when the age specific death rates. What is ASDR? ASDR, I'll write down the separate full form. ASDR, age specific death rates. Age specific death rates. So if the age specific death rates of the comparing population is available, in those cases I am going to directly standardize. If it is not available, you have to do indirect standardization. Right? That's the only thing that is being asked. You're not going to ask like this is the population, this is the age specific death rates, do the direct standardization. It's not possible. So please note that for the indirect standardization, we always calculate something called as SMR. In indirect standardization, we will calculate something called as the SMR. SMR stands for the standardized mortality ratio. Please note, it's a standardized mortality ratio. What is the formula of SMR? It is the total number of observed deaths. Number of deaths that the total you are observing divided by the total number of expected deaths. Expected deaths in the area multiplied by 100. Please note, it's a ratio expressed in percentage. But the point is, the essence is, it is a ratio. The essence is, it is a ratio. The observed deaths are not out of the expected deaths. The observed deaths are separate, the expected deaths are separate. If the standardized mortality ratio is more than 1, we think that whatever occupation you are doing, assessing, that occupation has higher death rates. It's a high risk occupation compared to the reference standard. Listen very carefully now. Let us say that the standard mortality ratio of any population was less than 1. If the standardized mortality ratio of any population is less than 1, that means what? It means that beta, whatever occupation you were assessing, the deaths in that occupation is less than 1, right? SMR is less than 1, so the observed deaths are lesser than the national population or the standard population. Therefore, we say that the occupation is not high risk. So please note that what do you understand by the SMR? The SMR, if it is more than 1, that means the occupation or the group that you are assessing is a high risk or not high risk. It is a high risk occupation. Why? Because it is the total observed deaths divided by expected deaths. So if the SMR is less than 1, that means whatever occupation or the group you were assessing, that group is high risk or low risk. That is common sense, low risk. If it is equal to 1, that means it is at the normal risk. So that is what is standardization. But a standardization is of two types. Standardization could be a direct standardization. Standardization could be indirect standardization. So that was most of your 90% of the topics that you need to study and understand in this video. Now, before we close off, let me just have a word regarding some of the boring topics. I'm very sure that these are the MCQs you are not going to get now because there is so much comprehensive and exhaustive understandings and integrated medicine. So these type of MCQs are not normally asked, but all said and done, let us have a very quick review about these eminent personalities and the study trials which are important. So the father of medicine, that is Hippocrates. Who's called as the father of epidemiology? It is John Snow. Please note that John Snow was his famous experiment on cholera epidemic. That was a natural experiment on cholera. Cholera experiment is what is John Snow. Who's called as the father of public health? It is a disease, that is cholera. Who's called as the founder of epidemiology? That is Fracas Torius. Who's called as the father of vaccination or immunology. So it's not about immunology, it's the father of vaccination, that is Edward Jenner. He gave us the first vaccination. He gave us the concepts about vaccination, about smallpox vaccine. Next is, who's the founder of evidence-based medicine? It is Gordon Guyatt. Who's the father of evidence-based medicine? That is David Sackett. Who's called as the father of Indian surgery? Sushruta. And father of homeopathy is Samuel Hahnemann. Some of the MCQs which you may be asked about, who gave us eminent personalities, who gave us the different theories. The germ theory of disease was given by Louis Pasteur. Vaccination term was coined by Edward Jenner. Web of causation was given by McMahon. Please note it's a McMahon. The A is before the H. The multifactorial causation was given by Patton Coffer. Criteria for causality, or also called as the Hill's criteria. This was given by Dr. Hill's criteria. This is also called as the Hill's criteria. It was given by Doll and Hill. So these were some of the eminent personalities. Some of the MCQs which may be asked about the landmark research trials. Vitamin C and scurvy was done by a landmark. It was one of the first intervention studies which was documented. This is by Dr. James Lind. DVT, breast cancer and oral contraceptive was done by Doll and Hill. Macrovascular and microvascular long-term complications in diabetes is one of the longest or the largest studies that we have in diabetes. That is called as the Accord trials largest cohort study. It is also the largest cohort study. Even if the MCQ says about heart or not, it is the Framingham heart study. Growth charts for monitoring the growth. So, of course, growth charts, the WHO growth charts we have are based on the Boston standards, but there are other growth charts also which we used in India. So, that is based on the MGRS. So, that is what is MGRS study. MGRS, that is multicentric growth reference study. Multicentric growth reference study. That is what is MGRS studies. The next is largest international clinical trial to assess for the treatment of COVID-19. So when the COVID-19 pandemic had just started, a lot of countries had started doing research on how to treat COVID-19. It was a novel disease. So there was a big trial that is called as the Solidarity trial. That was to assess the treatment across the countries, across researchers on a single platform. So it was one of the largest evidence-based medicine that we had made, that is Solidarity trial. Other landmark research studies, mostly for coronary artery disease or the ischemic heart disease, is MR-FIT trials. These are the multiple risk factor intervention trials. Basically, MR-FIT trials was to find out the effect of lifestyle modification on ischemic heart disease, on coronary artery disease or the ischemic heart disease, to understand the effect of smoking cessation, physical exercise, diet, nutrition, healthy thinking and positive thinking. That is what is multiple risk factor intervention trials. What is this Oslo trial? Oslo trial was to decrease smoking and to decrease the lipid levels, and the effect of smoking and lipid levels on coronary artery disease was done by Oslo trial. Multinational monitoring of trends and determinants in cardiovascular disease. This was a large trial called as the Monica trial. It was to study many risk factors and associated factors for cardiovascular diseases. Stanford trial, this was a 3-community trial. Different communities were taken and different types of health education was given. So this trial was to find the effect of health education about telling the people that what should be their normal BP, what should be the diet pattern, how should people live. So health education and the effect of coronary artery disease. This was large Stanford trials. So these are some of the landmark trials that are there. Of course, I hope that you do not get any MCQs on these, because these had been some years back, they were the questions. But nowadays, I don't think that these will be the questions. Thank you so much for watching this module. See you in the next video, where we are going to discuss about descriptive epidemiology.